Lesson 9.1, factors and greatest common factors. Want to factor each number. Well, the only ones that actually go into 23 are 1 and 23, so we call that prime. 36, we build our tree, and hopefully this is a review for most of you. So we say the prime factors are 2, 2, 3, and 3. Sometimes it's written with multiplications. I don't really care. So 8 is 4 and 2. And 72. Two times 2 times 2 times 3 times 3. So that leads us to what definitions of prime. Prime, the only factors are 1 and the number. Composite means there's just more than that. So it's not just 1 in the number, there's a 2, there's a 3, extras. So what do we care for? Well, we're building up to factoring monomials, which will build up to factor binomials, which will build up to actually solving equations, which we'll be doing by the end of this lesson. So what goes into here? 2 times 2 times 3 times a, because it's a squared, times b times b times b, because it's b to the third. So we actually have to break out the number. In this case, we are going to put the negative as a -1, just so we remember that it's there. So we'll get -1 times 2 times 2 times 2 times 3 times p times q times q. Finally, a little bit of an easier one, on the number side anyway. 5 times x, 5 times y, 3 times. So now the question is, how do we find a GCF? And we use everything we just worked on to find a GCF. What does that stand for? Greatest common factor. And what we're saying is we've got two terms, or monomials, and we want to pull out what we can from both. And we want to pull out the highest possible value. So I know the highest value, just looking at this, is 4. So I would just say 4. That's it. And this one looks like there's a 2, and then an a, and then a b squared. And what we want to do is get good at pulling out GCFs so we can start actually factoring a whole actual binomial and then solve it. So that's where we're going now. We're going to back up and look at the distributive property, which we've done previously. How would we distribute this? Well, we'd multiply the first term. The numbers are 6, variables x to the third. And we multiply the second term, where we get -8x. Now we go backwards. We call that factoring. So we have 6x to the third minus 8x. And what I like to do, not everybody does this, is divide, just so I realize that I'm pulling those numbers out. And I look at the 6 and the 8 and I say 2, the x to the third and the x. So then I rewrite it with the 2x out front. We have an x squared got my 3x squared minus 4. That's factoring. You're going to do a lot of it in the near future, so try to get on top of it as soon as possible. So we'll give a couple examples here. If you want to pause the video and try them yourself, go ahead. What I strongly recommend is when you're done is look at the term that's in the parentheses and just double check. Is there anything else that can come out of this term? No. Looks like I got it right. This is 3 terms. Doesn't really matter. What's in all 3 terms? Watch out for your negatives. They can cause problems. Is there anything in these 3 terms I can factor out? Looks like a 3, but I can't here. How about an X? Can't here. How about a Y? Nope. Done. And now a trickier form of factoring. We call it grouping. Dead giveaway on grouping is that there are 4 terms. Can't group with 3 terms. What you do is you look at the first 2, and then separately look at the second 2, and you pull out everything you can. And if it works, you'll end up with a common term. So in this case, I know that there's a 4b in there. And that leaves me with a plus 2. In the second term, there's a 3 in there. Leaves me with a plus 2. At this point, I realize I've done it right. At least in this fabulous math world where the math teacher sets up the problem. Because there's an a plus 2 left. So 4b plus 3 comes out, and the a plus 2 stays. And that's how you factor by grouping. A lot of people are mystified by this. If you don't quite understand it, just notice if I do all the distribution, I've gotten right back to where I started. So that's how we factor by grouping. It's a neat little trick. Even if you don't quite understand it, you can see how it works. Try the other one on your own. There's a trick in there, so be careful. At this point, you're probably saying, didn't work. Stupid math teacher screwed it up. In which case I would say, no, you screwed it up. You should have factored out -3. And then you would have ended up with this. So this is using the -1 property. It's pretty slick. Watch for it. Whenever you see a term that's off by just a negative, that's when you apply it. And there's a lot to keep straight here, so you'll be working along, doing the best you can, and then suddenly, hey, this doesn't work. That's when you got to stop yourself and say, hey, this might be one of those negative property ones. You can redistribute that if you want, see if it works, but I'm pretty sure it does. So last page, why are we factoring? Well, it's going to let us solve second order polynomials. 2x minus 1 equals 3. Don't write this down. You've already solved that. Piece of cake. Well, we're not doing that anymore. We're doing bigger ones. We have an x squared plus a 2x. Get x alone. Can't. Confusing. We want to get something down to a point where we get to use this, which means that we have something, call it x, and something else equals 0. What this means is we can break the problem in half and say, well, you could equal 0, or you could equal 0. And either way, the problem is going to have an answer. Notice it now has 2 answers. That's because it's a second degree polynomial. Should have 2 answers. Sometimes it's the same answer, so it's repeated twice. Don't worry about it. It gets confusing. Let's just put it into action and see what it does. X minus 3 times x plus 4 equals 0. Break it in half. Either one of these could equal 0. If I put in 3, this one's 0, this one's 7, but 0 times 7 is 0. I put in -4, this one is 0, This one is -7, but 0 times -7 equals 0. Works. This one looks a little bit confusing. It's not. Break it apart. And again, you put in a equals 0. Well, this is -3, but who cares? This is 0. 0 times -3 is 0. Put in 3. 3 times 0 is 0. It works. And finally, we put it all together. Factor and solve. Remember, when I show the little division, I'm not throwing away the x. It's just my way for factoring. And I'm shortcutting right here. I know x plus 4 equals 0. I know x equals -4. It's just going to be the opposite of the sign. A little lazy, but it works for me. This is a grouping. How did we know? Because there were 4 terms. Did we do it right? X plus 3, x plus 3. We did it right. Here's where I said I'm going to shortcut. X plus 2 equals 0. I know that's going to be x equals -2. If you don't like that, write it out. X plus 3 equals 0. Subtract 3. I'm just saving myself some time. These look a little trickier, but here's the key point. Remember, set equal to 0. Get students in high-level math who forget this. They've just gone through the motions all the time, done their little factoring, and moved on. Always set it equal to 0. Try and finish that one on your own. Now, later on, we'd actually combine this 6 and this 2, but we're not going to do that now. We're going to leave them separate. Try and guess why. Hopefully you guess that it's because now I can group them. Try grouping that on your own before I do it. Do we do it right? I always have that mentality in my head. Stop and ask. Did I do it right? Yes, I did, because I have x plus 2 in both parentheses. And that's it. Highly complicated stuff. Bring your questions to class. We'll practice. Takes a lot of time. Good luck.